All right, let's try this for the third time, ladies and gentlemen. The first time, didn't work. Second time, I forgot to hit the record button, so we're going to try this again. This is the first function family that we're going to start. Obviously, all of these are functions, and we are going to look at how this actually is this. This is pretty much the same thing as the proportional graphs. If you notice, I gave you a sample here. Remember how they start? They had to intersect the origin. It was a straight diagonal line. Obviously, this is only the first quadrant, and we call the constant, constant rate or constant of proportionality, the common ratio, and that would be k. And basically, now, instead of calling it constant of proportionality, we're going to refer to that as slope. And k obviously can have positive and negative values, and we're going to talk about that. So, as we look through here, we're going to look at how filling out tables, graphs, how k affects the graph. So by the end of this lesson, hopefully you guys will see the difference of how k values affect the lines. Obviously, it's not just going to look like this graph anymore. It's going to you're going to be able to see all the different aspects of the direct variation. So proportional graphs, one more thing before I move on. Remember, we call these proportional graphs. They're proportional because it stays, it starts at the origin and it stays a straight diagonal line. But now we're going to refer to them as a direct variation function family. All right, now we have two equations. They're both direct variation equations. You also would refer to these as proportional equations, like we called before earlier in the year. So because they are direct variation, only multiplication is involved, and we're going to fill out the table. So we're going to take an equation. We're going to use these 5 values. I call them the Fab 5 values, and these are the most commonly used in linear functions or direct variation functions. They're all lines. So we're going to use -2 to 2, and then we're going to fill out the y value, the output. And if you notice, when you plug in x, if you multiply by 2, that's going to get your y. So how this works is you have your 2, and we plug it in, just like we did with all expressions. We plug in our x values in here. So we have -2, -1, and so on. Most of you could probably do this in your head. So -2 times 2 is -4. -1 times 2 is -2. 0 times anything is 0. 1 times 2 is 2. And 2 times 2 is 4. Now, if you notice, some of you might see that the distance from here to here, here to here, here to here, here to here, a little q, it's 2, 2, 2, 2, and it's going up 2, and if you notice, there's your k. So if it's going down 2, like the next one, obviously our pattern's going to go down 2. So your y pattern, down your y, obviously helps you know what your k is and helps you figure out if you filled your table in. So there's your first t-chart, and obviously when we do this, these are called ordered pairs, and we're going to graph these in just a moment. All right, so now let's go over to the other equation, which is y is equal to -2x. And so here we have, we're going to plug our x in there, and -2, and we have -2, which is equal to 4. -2 times -1, because the negative times the negative is a positive. 0 times anything is 0. 1 times -2 is -2, and 2 times -2 stays negative. Again, if you look at the pattern, look at what direction we're headed and how much. Hopefully you guys all see that these are -2's, which obviously are our k values, so we filled it in correctly. A lot of times when you get really good at this, your k value or your k value can actually help you fill out your tables a lot quicker. Remember, patterns make things easier. These are patterns that you see within your y output column. All right, so we have these filled out, and what the purpose is that I want you to take an equation, fill out a t-chart, and then be able to graph it. So right now, if you notice on your sheets, it should say y is equal to 2x, not 3x. So change those, they're the wrong one. So they should look like this. And then we're going to plot those tables. You're going to take the tables that we just did, put them in ordered pair form, x, y form, and graph them. So we had -2, -4, -1, -2, 0, 0, 1, 2, 2, 4. And then you need to take a straight edge and make a line. And make sure there are arrows on each of those. Now you're going to plot the other one. We have -2, +4 this time, -1, +2, 0, 0, 1, -2, and then 2, -4. Again, take a straight edge and connect the points. Now, if you notice, a couple things I told you, our K values tell us a lot of things. First of all, if you imagine yourself walking on this line, left to right, look at the direction you're headed. And I want you to compare the direction you're headed and the K value that you have in each of these. Does it make sense that the left one, you're walking up the line, K is positive. Does that make sense that positive goes up? And then if you walk on the right-hand side, the -2x, you're walking down the line, left to right, and our K value is negative. So negative and positive K values tell you the direction the line is, which is called the trend, or which way it slopes. Okay? You know, slope is steepness of a line and the direction the line is headed. So we have trend. So positive and negative K values tell us the trend the line has. So before you even start your tables, you should know what type of graph you're graphing. If they're positive, it should be going up left to right. If it's negative, it should be going down left to right. So now let's look at this one. We have it also, oh, one more thing before I forgot to mention this. If you look at the K values, also one thing that I'm going to ask you guys to look at is take the absolute value of each of those K values. If you notice, the absolute value of 2 and the absolute value of -2 is the same, which means these lines are the same steepness. Look at them. Just one's going up, one's going down. Pretend that on the left-hand side, you're walking to your friend's house, which is up top of the hill. Your house is at the bottom of the hill. Now, the right-hand side, now you're going back home. Think of a street. Does the road change steepness, no matter if you go up or down it? It's the same. It's just the direction that you're headed. So just keep that in mind. If 2 Ks, if I ask you, if I give you 2 equations, which one's steeper? You look at the K value. Whoever's absolute value, if their absolute value is the same, they have the same steepness. If the K is larger, obviously it's going to have a higher or a steeper line. Higher the absolute value is, and smaller the absolute value, the less steep the line is. So at this point right here, if you compare absolute values, we're at the same steepness. They just, one goes up, one goes down because one's positive, one's negative. Okay? Now let's try this. First of all, before you even start this line, what direction should this line head? What kind of trend does it have? Look at the K value. We just talked about what positive and negative K values do. So the K value, obviously, is negative. Good. And think about what direction that's going to head. Before you even fill out the table, you should start thinking about where your line is headed, like what direction the line is going to be, what trend it has, and thinking about the steepness. Compare the absolute value of this K value versus the other two that we just graphed. All right, so here we have -1/2 times a -2. We have -1/2, and we're going to plug in the next x value, which is -1. So negative times a negative is a positive, and what's half of 2? 1. Negative times a negative is a positive, and what's half of 1? Good. What's 0 times anything? What's 1 times, well, we can do this. We have -1/2 times 1. Well, what's negative times a positive is negative, and what's half of 1 again? And a negative times a positive, which is this 2 times negative 1/2 would be 1 negative, stays negative, and what's half of 2? 1. Very good. Now we're going to graph this. Now again, before we graph it, what direction should this line have a trend of? So what type of trend should this line have? That's what you should be thinking in your head. Are my points going the right way? So we're going to start with negative 2, 1. We have negative 1/2, 0, 0, 1, negative 1/2, and 2, 1, negative 1. Hey, there's the bell again. Imagine that. Now, if you guys look at this, again, if you go left to right, okay, we are headed in the downward trend, and that's good because we have a negative k value. And think about the steepness. Which one of these is the steeper one? Are these steeper than that line? Or is this line less steep? That's the question. Now, this problem right here, the negative y is equal to negative 1/2 is actually number 5 on your activity packet that you should have in front, including the notes. You can obviously transfer this over onto your number 5 and then graph it on the graph paper, which is the second page. I would suggest ripping the two things apart so that you guys have obviously access instead of having to flip-flop. You're going to graph all 6 lines on the graph paper. You also need to make sure that, like, I'm putting number 5 at the end of that when I put it on my graph paper, so I know that that's number 5. So then we can do some comparison, and we can talk about each of the lines and see how they look and how yours compare to mine. So your goal today is to graph the remaining 5 on the activity sheet, fill out your tables, plug in your x values, get your ordered pairs out, graph them on the graph paper. And if you have any questions, make sure that you utilize, myself and Mr. Bolin as needed. So I hope you good luck and have a great day.